What is up, guys? It's TimeForDillon back at it again with another crypto video. What is up, guys? It's TimeForDillon back at it again with another electronics tutorial. Yes, of course, we are continuing on with our Elegoo Uno R3 most completed starter kit in the universe. And I'm showing you guys part 2 of our little mini tutorial series where I show you guys how to build this awesome radar system. It's really not radar, it's SODAR, but you guys get the drift. Now, in our last lesson, I showed you guys exactly how to set up the board, the wiring, everything you need. We have a servo, we have our little ultrasonic sensor, and then of course we connected all of that to our Uno R3 along with, wait for it, an active buzzer that beeps as you get closer, if you can hear that. I think you guys can. So we showed you guys how to do that in the last lesson, and I told you guys today that I would be showing you guys how to set up this radar system that shows red lines as we appear, boom, bing, bong, bing, bong, on the radar. So stay tuned until the end of this video. We're going to show you from scratch exactly how we're going to build this program, graphical user interface. This language we're going to use is Java. So far on this channel we have not talked about Java, but you guys now know how to program in C++ as well as Python if you took my 2 Python tutorial series, or if you just completed the series by yourself on sololearn.com. Either way, you guys now know how to program. Even if you don't, you can still follow along. I'm going to walk you through the exact steps. By the end of this video, you should have a basic understanding of how everything works in this Java program. So without further ado, let's get started. Let's jump right into this video. Let's not waste any more time. What we're going to do is we're going to start this out with a new project. So let's go ahead and stop this. Boom, we're going to pull up a new project. I'm just going to go ahead and close this. Save it. Bingo, bango. Now from this point on, we're really not going to need to look at our electronic device, but just make sure that it's plugged in if you guys have built it so far. That way we're able to read all of this serial data. Now this is the data that we need in order to make this sucker work. Now if you guys finished off with our last video, everything in our code is the exact same except for one thing. I changed one minor thing with our code in order to make this work. And the reason why is because in order to get this program, over here in the processing IDE, to pick up the data that's coming out of our Elegoo device, we need to pass it over through the serial monitor. So the way that we did this, right, is we have this function that we use called print distance. And what I was doing, what you guys did too, if you copied my code, is we had it so that it prints out to the serial monitor the distance followed by the cm, centimeters, right? So we know what the distance in centimeters is. We would end the line with that. So what we're going to do instead is we are going to pass 2 things. I, which comes from the for loop that we're doing, which essentially is the angle. So the I value is the angle, and then of course we're going to also pass in the distance, which comes from the mySensor.distance method, which is, the value that we're saving up here as a long. So the only thing you need to change with this code is in this print distance function. You can just go ahead and delete these 2 things, the print distance and print cm. You can delete those. We don't need them anymore. And we need to include, up here, we need to include this int I. So it doesn't matter where you put it. You can put it at the front or at the back. I put it at the front, int I. And down here, when we make the function call, we need to add the I as well. And it needs to be inside of the for loop. So right where we were calling this originally, the print distance function, originally what we were doing was we were passing in distance. Now we're passing in distance as well as I. So we're passing in the angle and the distance. So that's the only thing you need to change. And make sure you change it in this function, which is the second for loop, which is sweeping back. And then in the first function, or the first loop as well, which is the one that sweeps forward. So, or forward for your view and then back, right? So just in both of these function calls, make sure you include I so that we're sending in the angle. And then up here, what we need to do is we just need to print it out. Now, we need to make sure that we separate it by something useful. and then end it with something useful. Because when we're trying to decipher the text in our processing environment, we need to be able to determine a good stopping point from pulling, first the angle data and then the distance data. So the way I'm doing it is serial.print I. So it's going to print out I, which is the angle, followed by a comma. Then it's going to print out the distance, followed by a period. And that's why when you look at it in the serial monitor, you'll see that there's all these different data values, right? 17, 98, period. 116, 98, period. So basically all this data, this is going to be the raw data that we're going to be using in our function over here in this program. So to get started, now that we have this set up, right, you run the code, put it into your device, make sure that it's working properly, which it is, bingo bango. So now that it's working, what we can do, this is very important. You need to close the serial monitor. Otherwise, this program will not work. Only one program can be running the serial monitor at a time. So if you click this and you leave it open, this code over here is not going to work. So just keep that in mind. And as you guys can see, once you click run from the serial monitor, you can see that the numbers make a lot more sense. So 0 is the angle, 1 is the angle, 2 is the angle, 3, 4, 5, and so on and so forth. So that's pretty much it for this guy. And over here, now we can start writing our code. So the first thing we're going to need to do is we're going to need to set up our environment. So we're going to need to import this library. And when you import in Java, you can import certain aspects of a library. You can see it, boom, processing right here. This is exactly where we're getting this from. Serial port, and somewhere in here, right here, import processing serial. So what this star means, the asterisk, is basically we want everything from the serial library, from the processing.serial library. So you don't need to take everything. You could, only get certain things from the serial library, but we want everything. And you'll see that later if you do end up taking more Java classes. Sometimes you don't want to do this. Sometimes you don't want the star because it will import a lot of data, which, when you're trying to develop programs, you don't want it to take up too much memory, right? You want it to be optimized. But for our case, we want everything, so we're just going to put that. And then what we need to do is we need to start our setup function, kind of like over here in our Arduino, how we have our setup and our loop, except over here, all we need is a setup. And then we're going to be creating other functions as well that are important in terms of putting stuff out there. So for now, the only thing we really need to do is we need to create a rectangle. So I did it 1080p, 1080, 720, boom. Just like in C++ and Java, you need to end everything with a semicolon. We're going to run the smooth option, the smooth function, which just makes everything that's graphically user interface created much smoother and run much better. So we're going to run that, and then we're going to go ahead and create a function or create an instance of a port of the serial class, which is coming from our processing.serial library. So basically, we want to create a new serial, and inside of the constructor, we need to say a couple things. So we need to say this, and then we need to define which communications port we're using over here with the Arduino, and you do that from looking here in the port, COM3. We need to say it, COM3. COM3. Boom. And then, of course, just like we did over here, we need to set the baud rate, so 9600. Now, in order to have this work, we need to add the serial variable descriptor at the front of our variable name. Because this is a part of the serial class, we're creating an object of this class called myPort. And we're setting it equal to, boom, a new instance of the serial class. And the way we're defining it is with this information. This, which says this object, which communications port, and the baud rate. Boom. Now instead of defining it here, what I want to do, because if you guys remember from our last tutorial, if you put stuff in a block of code, you can only use it there. So we need to define it up here outside of the block of code so it's global and can be accessed by any part of our program in any other block of code. As long as it's up here, we can define it. We can pretty much have it work anywhere. And then another thing that we need to set up in here is a font, which we can do later. We really don't need to worry about the font now because eventually we're going to want to output some text. So let's see what happens when we run this. Boom, we got our little box. Very cool, so it definitely works. So what we need to do now, I think the best way to do this would probably be to just set up the serial data, meaning pulling the data from over here, the serial monitor, pulling this data into here and assigning it to variables. So to do that, what we need to do is we need to set up a couple variables. So we have our serial port. What we need to do is we need to create, because all of this is coming in as a string, right? Because we're printing it out over here. Boom, printing it out, it's coming into here. We're not going to pull it into here as a string. So we need to do string raw data and just set it equal to an empty string. And then what we need to do is we need to create ints that will hold this data. One for the angle and one for the distance. Boom. So what we need to do now is we need to create a function that is going to pretty much call on this serial data information. So what we need to do is we need to create a function. Just like the setup, we're not going to be returning anything. It's just going to be storing the information up here in the my port. So we could create a function that doesn't return anything, call it void. And we're going to call it the serial event. Boom. And basically what this is going to do is it's going to use the serial port, the serial my port. Boom. Boom. And there we go. We have our function. So what we need to do, first thing we need to do is we need to read in the data. So we'll have raw data, which is the string that we just created up here. And this is going to be equal to my port dot read string until. Read string until. And what are we going to read it until? Just like we set it up over here. Where is it? In our print function, print distance, we want to read it all the way until the period. So that's what we need to put. Use a single quote, then the character, and then another single quote. The single quotes in Java and C++ are restricted for characters. So you can have a single character in a string, but essentially a string is an array of characters. So if you're going to have a string, you need double quotes. If you want to have a character, just one single, character. One letter, one number, one symbol. It needs to be a single quote. And then, of course, don't forget the semicolon. Okay, now what we need to do is we need to make sure that this sucker is not empty. So if the raw data, right, the string, is not, so the exclamation point equal to, this means is not equal to. It's not equal to null, then we are going to run this block of code. And this block of code is essentially just going to go through this string that we have, which is the angle, comma, distance, period. And we're going to separate the comma and the period. We're going to get rid of those and then use the first number as the angle. We're going to store that into our angle right here. And then the other part we're going to store into the distance. Okay, so to do this, what we need to do is we need to say, let's think about it, raw data, because we have, so far we have, boom, we're pulling it into raw data, and this thing is going to run every single time some new piece of data goes into the serial port. So raw data is going to equal raw data dot substring. So substring, you guessed it, all it does is it breaks up a bigger string into a smaller string. And the way that you do this is you have two indices, because remember a string is an array of characters. So the first index will tell you where to start from. The second index will tell you where to end. So what we're going to do is we're going to put a 0 for the start, because everything in an array is 0 based. 0 being the very first index. and then we are going to go until the end of the array. So to do that in Java, it's very easy. Just do raw data dot length. Boom. So that will give you the length, right? But we don't want the length because think about it. If we have a 25 character long array, to get to the 25th character, you need to do the 24th index because it's 0 base. 0 to 24 would be 25. So we just need to do length minus 1. Boom. So what is this doing? Removing the period at the end. Boom. And I put a period at the end. But you get it. Okay. So now that we have that period gone, what we need to do is we need to find where the comma is. So I think the best way to do this is, the way I did it at least, is I create an index. We call it comma index. And what we're going to do is we're going to save the raw data index of, boom. So basically what index of does, see, these are all methods of the class string, which is pretty cool. Just like we have, methods. Where is it? Right here. Read string until. This is a method of the class serial, right? And we're using it by putting a period after the object of the class that we created, and then boom, putting the function. Okay? Basically, a method is a function tied to a class. You can only use it if you have an instance of that class. Same thing here with raw data. Raw data is an instance of the string class. And in order to use index of, we just call the instance of that the object, which is the instance of that class, right? We named it raw data, period, and then the function, boom, which is the method, because we're talking about a class. Okay, index of, the way it works is you put in a character for the string, and wherever that character comes up in the string, it's going to return a number, which is the index in that array. So boom, because remember, a string is an array of characters. All right, so index of, we want the comma, right? We want to know where the comma is so we can get everything before it and everything after it. Boom. Pretty simple, right? So we have the comma index, which is raw data dot index of. And now what we need to do is have another if statement. So if comma index does not equal -1. And the reason why we're doing -1 is because if there is no instance of a comma, this function, this method, will return a -1. So you got to do, if it's not equal to the -1, which means it found something, boom, run this code. Now you could make this code a lot more professional by putting in exceptions, which is something that we covered in the Python tutorial. Exceptions just basically handle problems in the code. So instead of getting a bug and the system just ends because it can't handle it, you run exceptions so that in certain cases, like let's say we want a number and it only has letters or some case like that, boom, it'll just have you re-enter something or something like that. You know what I mean? But we're not going to do that. Not in today's lesson. Okay, so if we happen to find a comma, right, what are we going to do? So we need to do two things. So I think how we need to do this is we need to have a new string. Two of them. One of them is going to be angle from the raw data. And I like to name my variables like this so I can read it and know exactly how this code works. Some people just put A, B. It's so hard to figure out how the code works. For me, I like to make it readable for an English human being to understand just reading it. They can kind of figure out how it works. Okay, so we have a string called angle from raw data. And basically what we're going to do is we're going to, boom, we're going to say this is equal to raw data dot what? Dot substring, just like we did up here, right? We're just redoing this line of code, except this time, since we don't have the period, we have the comma. We're going to go from the beginning to the comma for this one. Okay, let's see. So we got 0, comma index. That way we go from the beginning of the string, boom, to the comma index. And then we're just going to literally do this exact same thing, except instead of it being angle from data, we'll do distance from raw data. Distance from raw data, boom. Except this time, instead of doing 0 to comma, we'll do comma. We actually need to do comma index plus 1. And then we could do raw data dot length minus 1. But if you just leave it blank, it'll just get everything after. So we'll just do that. Boom. So comma index plus 1. That will get everything from the comma onward. Boom. Not including the comma. If you don't have the plus 1, it's going to get the comma. So just do it like that. Comma index plus 1. So it goes to the one after the comma and gets everything after it. Okay, cool. So after we have that, see, and the thing that's tricky about dealing with the processing environment is we can't really check this code until we're done writing it. But I'm pretty sure this is going to work. Okay, so now what we need to do is we just need to turn these strings into ints. So luckily in Java, there's a very easy way to do that. So far we have our angle up here. So angle is going to equal int, and this is exactly how you would do it in Python as well. Boom. Angle, why do we keep inserting? Angle from raw data. Boom. So that's going to store this string. It's going to turn this string into an int. Boom. Put it in there. Now, if there's letters in there, it's not going to work. There's going to be an error. This is where you would use exceptions. Except we know it's going to work because we've worked everything out. So we're not going to have a problem. And then we need to do the same thing. Distance equals int. Boom. Distance from raw data. Boom, boom. There we go. All right, so I think that's good for now. Let's go ahead and run it just to make sure it's still working. So boom, and yes, it is. It is in fact still working. Awesome. Okay, so now what I want to do is I want to add a new function. We're going to call it draw. Boom, and of course we're not returning anything from here, so just make it a void return type. Boom, and basically to draw. So far we've set up our screen. We said everything that we put in here, make it smooth. We've set up our serial port, right? My port, which is a serial object. We've set up our angle, our distance. We've received the raw data from the port. We have our port. We included our library. We have all this code that basically pulls in the raw data as text and turns it into ints or numbers. So now we can use the numbers. So now what we need to do is we need to create the environment that all of this is going to happen in. And this is where the draw function comes in. So we're going to have a couple functions. We're going to have the draw, which puts everything out on the screen. We're going to have a draw radar. So what the draw radar is going to do, and we'll just boom, go like that for now. Actually, we could put that at the bottom. Draw radar. Draw radar, so that's going, so the draw radar is going to be the circles that we have. Boom, 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 boom. So it's like the base. Then we're going to have another one, draw line. We're going to have draw line. And what draw line is going to do is draw the green line that is sweeping across. Boom, boom, boom. And then we're going to have one more, draw object. And the object one, actually we're going to have two more, I lied. The object is going to be if we pick up an object in range. So that's what this one is going to be. And then the last one that we're going to do is draw text. And you guessed it, the text is going to be what's on the bottom of our screen. Okay, so we have our draw radar. Boom, draw line, draw object, and then of course, draw text. Okay, so the first thing we want to do is draw the radar, then we're going to draw the line, then we're going to draw the object, then we're going to draw the text. Okay, so to draw the radar, basically we need to set up a couple things. We need to set up the rectangle, which is the black color. So to do that, we need a rect, which is a rectangle. And this takes in 4 parameters. So the first one is basically where you want the rectangle to begin. So do you want it to begin boom up here, like for example in my green screen? Do you want it to be right here? Whoop. Or do you want it to be like right here? So we're gonna put it boom right at the top at 0, 0, because the top, this point up here in the rectangle, which would be up here on the screen, right, is 0, 0. So that's what we want to do. We want it to start in the top corner. So 0, 0. And then we want it to basically fill up the screen. So instead of guessing or putting in these numbers here, 1080 by 720, we could just put width and height. And then we need to also make sure that this is colored. So we want to fill it. What I found is 0, 4 is the best for this case, which is like a nice black color. And then what we need to do, I'm sorry, I made a mistake. So this stuff goes up here in the draw function, not in the draw radar. First we need to draw into our screen. Then we're going to start drawing the different elements on top of the screen. So boom, boom. This is basically going to create a rectangle in our little space. So let's run it and see what it looks like. Boom. And as you can see, the reason why you put this 4 at the end is to make it kind of, as you guys saw, it makes it like pulsate. And this is what's going to give the green that weird ghosting effect. So we want, basically after testing this a couple times, we only want this ghosting effect to be where the radar is going to be. If we have the text at the bottom with this ghosting effect, you can't even read the text. It looks retarded. So the best way I found to do this is to just subtract 50 from the rectangle. So basically, it's going to fill up this rectangle, starting up here, 0, 0, and it's going to go to the width, boop, and then the height, minus 50. So it'll give you like a little box, and you can just play around with the numbers until you get it right. But I found 50 works good. So boom, run it, and as you can see, we now have this little box at the bottom, which we can fill another rectangle, which I like to do at the bottom after all of these functions. So let's do it. And if you guys didn't know, the double slash is a comment, so it'll just ignore this. Since we're not calling these functions, we don't need to put anything in them yet. Okay. So now what we need to do is, boom, fill. And another rect, which is where the text is going to go, which is down here. So how are we going to do this? We still want it to start, boom, over here at 0, but not 0, 0. We want it to be at 0, and then wherever this point is. So this point happens to be this right here. So it's 0, height minus 50. And then how tall do we want it to be? And basically we want this to be width, because we want it to be the whole width. And basically the height, we only really need it to be 50. So let's see if this works. Boom. And it does work. As you guys can see, we now have this down here. Boom. We have a nice black box at the bottom that doesn't have any type of weird ghosting. And I did the triple zeros just for the RGB 000, which is black. If you wanted white, 255, 255, 255. And actually, now that I think about this, the draw text, actually, technically, we want it to be on top of the rectangle. I mean, I guess it really doesn't matter, but let's just put it after we put this radar in. So now we have our nice little box. Now what we need to do is we need to start drawing our radar. Okay, so let's think about it. How do we want to draw the radar? All right, so now to draw this radar, what we need to do, in order to draw stuff in Java, we really need to do two things. We need to have push matrix, and we need to put all the drawing in between this and this. Now, I remember learning this in school. I don't remember exactly what it does. We could look it up. Boom. Java push matrix and pop matrix. Boom. Push matrix function saves current coordinate system to the stack. Pop matrix restores the coordinate system afterwards. So the stack, basically in memory, you have two things, the heap and the stack. Heap is for saving stuff like int, string, stuff like that. The stack is for storing memory that can be manipulated easily. So the best way I can think about it is, if you need an array of a fixed size, you use the heap. If you need an array that's dynamic, which means the memory can be dynamically added as it grows, you use the stack. But the problem is there's less memory on the stack than there is on the heap. So every time you use something that's on the stack, you want to make sure that you free up that memory after you're done using it. So that's basically what it's for. Alright, so the first thing we need to do is we need to translate and what we need to do is have the width divided by, because we want this to be right in the middle, you know what I mean? So width divided by 2 and the height minus 50. So basically what this means is, where do we start? We're going to start right in the middle of the screen, whatever the width is of the rectangle. Cut it in half, so boop, right in the middle. And then what's the height of the rectangle? Right, from here down to here, minus 50, boop, will be right here. So right in the middle of the rectangle, and 50 up from the bottom, which is right above that little black box that we created that's going to hold the text. Okay, so then what we need to do is we need to create a line. Okay, and then since we're just going to be creating lines, right, we're going to have circles of different size, right? We're not going to fill in the arcs. We want just the outline. So we need to do no fill. Boom. And then we need to say, how thick do we want it? We want it thick. No, I'm just kidding. We only want it to be 1 pixel. However much you put here, that's how big it is. So we want it to be 1 pixel. And then, of course, what color do we want it? This is where the nice green color comes from. I happen to remember. I wrote it down. It's 100, 250, 25. So this is that nice green. And then how many numbers do we want? How many numbers of these rings do we want? I put 4. You can put however many you want. Int number of circles equals 4. Boom. And then we need to figure out the radius of those circles. Okay, so this is just setting up for what we're about to do. I don't even think this will work if we run it. Let's see what happens if we run it. I think we need to finish what we started before we can even run it. Let's take a look. Yeah, so it still works, but see, we haven't printed anything out on the screen yet. So, not yet. So now we're going to get into the printing out part. So the way that we're going to do this is we want 4 circles. So how do we do this? If you said loop, you're correct. So let's go ahead and do a for loop. So for int I equals 0. I tends to be the number that everyone uses for loops. I guess because you're iterating through the loop. So I for the iterator. So we're going to say I starts at 0. I is less than the number of circles. See, this is why I like to name things appropriately, because it makes it easier to think it through, right? And then we want to increase by 1. So I plus plus, or you can do I plus 1. Doesn't really matter. Okay. And some people like to put this first bracket up here. They like to put it up here like that. I don't. It's totally a matter of preference though, but whatever you do, just remain consistent. Okay, so what is the radius of these circles? So let's test this out. Radius equals the width of the circle times I times 0.25. So basically, we want the radius to be based off of the width, and we want it to shift with the I value. So when the I is 1, it'll be this big, right? When I is 2, multiply it by 2 so it gets a little bigger. When I is 3, multiply it by 3 so it gets a little bigger. So that's really what we're trying to do, but we just kind of have to mess with the numbers until we figure it out. All of this divided by 2. Because we only want half the circle. And then we want to print this out. So to print it out, we're using the arc function, which prints an arc. And where are we going to start? We're going to start at 0, comma, 0, comma, radius times 2. So we'll have 2 radii, radius times 2. And then we're going to do pi and 2 pi. Okay, I don't know if this will work. It took me a while to mess with this and figure it out. I might even consult my notes if this doesn't work, because this was the hardest part for me. Okay, so let's run it. Let's see. Yeah, so it didn't print out. Oh, why is it not working, guys? Because I didn't uncomment the draw radar. Duh. Come on, people. Okay. I mean, that works. Basically, you just kind of got to figure out, mess with the numbers, try and figure it out. Or you can just ask it Google. Google will help you. That's really all that matters. Just try and figure it out. That's what makes this fun. Figure it out. That's the challenging aspect of this programming. It's figuring out how to make this work. Okay, but what we said was it was width minus width times that, and then minus 50. And that's how we were able to get all of them. Boom. So 1, 2, 3, 4. As you can see, there's nothing filled in here. If we were to take off the no fill, let's see what happens. See if it kind of fills them in. That actually looks kind of cool, but we don't want that. That's fine. Cool. So we have our radar system set up so far. Now what we need to do, because we have our serial data pulled in already, right? We have our serial data. We now have our radar. Now what we need to do is we need to get that line sweeping across. So let's do that. So next thing we need to do is, oh, you know what? We could draw the object first, I guess. So the line is the green line, the object is the red line. Let's do the object first. Okay, so just like we did with this, right? Because we're drawing stuff, we need to do the same thing. So push matrix and pop matrix. Push and pop. So in Java, as well as other programming languages, there's something called a vector, which is like, it's like the better array in my opinion. Because you don't need to establish the size of the array to use it. You can kind of just add things on willy-nilly and it will increase the size as you go. You use pop and push. And that also works in stacks and queues and stuff like that. So there's a bunch of other data structures out there we haven't even started talking about. But push and pop, basically we're pushing it off of a stack. So pretty cool stuff. Okay, so let's see. So to draw the object, what we need to do, just like we did up here, we need to translate. Matrix. And we want to use the same translation because basically just like in this case, right? We did width divided by 2, so boom, right in the middle, and then height minus 50, so we start here. That's exactly where we want to start with our line. We want to start here. We want to have it draw the line and then move the line along. Move it back. Or I'm mirrored on the camera, so it looks kind of funky when I move my arm because it's moving backwards. But okay, so we have our translate. Now we need to do just like we did with the last one, the stroke weight. We could do 1. So we will figure out what to do. And let's see, just to remember. RGB. Oh yeah, RGB. Red, green, blue. So for red, we just need 255, 0. That way it's just red, no green, no blue. It's just going to show up as red. Okay, and then we need to put a line. Now, of course, I've already figured out how to do this, but to figure out how to make a line according to the angle, right? How to print a line in Java at different angles. Draw a line at a specific angle. Boom. So Stack Overflow is a great website for programming help. Let me fix my green screen there a little. Basically, what we need to do is we need to have a line that has some combination of cosine and sine. And the angle, well, we have the angle, thank the Lord. Boom, it's up here. Angle. Okay, so to do it, we just need to put line 0, 0, 0, comma, 0, comma. And then what we need to do is back in this serial events page, we need to add something in here. And basically what we need to add is we need to have if distance is greater than 40, because in our example we're only doing 40 centimeters. That's the max distance that we're going to do. Sorry, if the distance is less than 40, we want it to be less than 40 to show up, right? What we're going to do is, first of all, make a new variable at the top, a boolean. A boolean is true or false only in computer programming. And we're going to call this show red line. Because think about it, we're going to have a green line sweeping across. If something shows up on the radar, we want it to show a red line, not a green line. Because we don't want it to show off the bat. We just want it to show if and only if something is in range. Okay. Coming down here. If something is in the range, we're going to set that sucker to true. So show red line equals true. Then what we're going to do is we're going to create, this is what we needed to make this line thing work. We need to create a new variable. And that variable float is called distance in pixels. Alright, so what we're going to do, right, is if, boom, we're in range, we're going to show the red line, and then we're going to do what? We are going to set the distance in pixels. In pixels. Because that distance is in centimeters, right? The computer doesn't know what the hell a centimeter is in terms of displaying something on a screen that is pixel-based. So to do that, what we need to do is we need to figure out how to map. Ding, ding, ding. That's the keyword, map. Just like we did over here with this function, map. We map the distance, boom, 40 and 0, max min, to these values, and these values were then used to make our beep interval, right? 50 to 1, basically. 50, if you can hear it, 50 at the max distance, 1 at the closest distance. So that's basically what we're going to do here, is we're going to map the pixels to the centimeters in terms of distance. So how long do we want the thing to be in pixels? Well, let's figure it out. So distance in pixels, the thing we're going to map is distance, and what we want is 0 and 40, right? The min and the max. And then what we want to do is we want it to be based on the height and the width of what we're dealing with. So we'll do the height, and then we need to create some type of multiplier. And the ones that I used was 0.025, and then this one we did 0.75. And those seemed to work perfectly for me. Boom, boom. Okay, and then if this isn't true, right, we'll run an else block. We'll say show red line equals false. Boom, close that block of code, and this looks pretty good. Now we can go back to our draw object function, and we can finish this sucker out. So we have 0, 0, and then we have distance in pixels, distance in pixels, and we're going to multiply that by a cosine. So cosine and a sine makes a tangent line. If you've ever heard that, I don't know if you've ever heard that, but that's basically what we're trying to do. We're trying to print out, if you guys know anything about the unit circle, basically the unit circle is created by using combination of sine and cosine, of which sine divided by cosine is tangent. But using sine and cosine, we can create a line to any point on a circle with radius 1. And if you just multiply the radius by something else, well then, you have a bigger circle. But essentially, a unit circle is with unit of 1 measurement of the radius. So just look up the math behind it, and you can figure out that this is how it works, basically. Or just take my word for it, plug it in. But I would suggest you guys try and figure this out on yourself if you can. But basically, this is how you do it. Boom, cosine. And then the next one will be negative distance in pixels times sine, same thing, radians, angle. Boom, boom, boom. Okay, now this should work. Let's go ahead and test it out and see, cross your fingers, if this thing works. Let's make sure to remove this. Boom, boom. Okay, cross your fingers. Run. Distance. Yeah, I spelled it wrong. Distance. Distance. Boom. Function distance in pixels. Okay, I did something wrong. Equals map. Rookie. Alright, map. Boom. Boom. Okay, this should work now. Run it. Sick. So it's totally printing out. Okay, this thing is way too thin. Let's go ahead and change this. Boom. So we need the, where is it? Draw object, the stroke weight. Let's do 10. Run it. Boom. Cool, so it's kind of working. I have my phone right here. That's what it's picking up. But it's working. The only thing is it needs to turn off when nothing is being popped up. But we'll go ahead and fix that later. Alright, so all we need to do now is just draw the green line and spit the text out. Okay. So for this line, same thing. Push, matrix, pop, matrix. And then what we're going to do in here is we are going to, just like last time, set the stroke weight. We're going to do it to 10, just like this one. Whatever you set this one to, set this one to the same. You can do 10, you can do 9, you can do 8, whatever. Doesn't really matter. And then, of course, we need to set the color, which we want it to be green. So it's basically this right here, this line right here. Just copy it, boom, paste it right here. Except we want it to be a little different. We'll just change it up a little. 50-50. Why not? Okay, now what we need to do is just kind of like last time, except we just want it a little different. Float center X is going to equal the width divided by 2, and float center Y is going to equal height minus height times 0.075, which is like almost all of the height except for 7.5%. So now we're going to do the line length. So this is going to equal the height times 0.75. So the line length, this number here is the multiplier. How long do you want the line to be? If you don't put the 0.75, it's just going to be the length of the height of our little rectangle that we're making. So 0.75 is 75% of the height of our rectangle. So this should be a good number, but we'll see. We can always adjust this number later if we want to change the size. Now what we need to do is we need to calculate. So we're just doing it a little different than this one, but basically it's the same thing. We're just making variables before we put them in here, just so you guys can see both ways of doing this. So we have float x2. So basically the way we're going to do this is we're going to do line, and then we're going to have the center x, the center y, and then x2 and y2. And this is what's going to print out our line. So we just need to tell this basically the same thing here. It's basically the exact same thing. So line length, L-E-N-G-T-H, times cosine. Same thing, radians, angle. Boom. And then same thing with float y2. It equals center y plus line length times sine of radians angle. The A-N-G-E-L or L-E? L-E. Boop, boop. All right, now this should work. And then we have our pop matrix. Cool, so this should work. Let's go ahead and run it. Boom. Oh, okay. I always forget. You gotta uncomment this. Let's stop it. Run it again. Okay, let's try putting the draw. Oh, draw line is on top. Let's close this, deploy it. Oh, we have our green line going the wrong way. I figured out why this thing, I had to look at my notes. As you can tell, this took me 2 days to write this, so it's not perfect by any stretch of the imagination. But the reason why, when I run this, we got our green line going the wrong way, or sometimes not even showing up, is because this needs to be a minus. Boom. There we go. So now we have our green line showing up. The only thing I need to figure out is why this red line is showing up. Alright, so for some reason, this thing is not working. So what I'm going to try and do instead is I'm going to get rid of this draw object. Let's just try this. We will comment out draw object. And we want some functionality like this down in this thing. So basically, what we want is, boom, we'll copy that, or we'll cut that, rather. We want to do if show red line is true, we want to fill in a red color, else we want to fill in a green color, basically. So this color is the green color, so we'll go boom, boom. We'll go like that. Let's try it. Okay, now what we need to do is we just need to have the length of this be changed based on the distance. So I think the best way to do this would be to just boom, take all the, actually, we can leave the height and the Y. Let's just take this and put it in here for the green. Boom. We'll take this, boom, and put it in here for the green. So this is for the green case. And then of course, boom, we'll take that. We'll put it in here too. And now what we need to do is just do this. Boom, we'll take that, we'll put it in here. And then instead of X, we'll do center, or 0, we'll do center X and center Y. And this should work. Let's try it. So it's totally working now, heck yeah. So it's it's a little different from the example I showed you. But you guys can just mess with this and make it work for you guys. That's all that matters. This works for me. It's a little bit different than the example I showed you at the beginning of the video. It's hard for me to just recall this out of my mind, so it's going to be a little different. I just made it work for this video. Just deal with it. If you guys want the actual code of the one that I showed you at the beginning of this video. Alright, so the last thing we need to do is just output the text. Let's see how we're doing on time. Okay, this is taking quite some time. So, to output the text, we need to do two things. We need to come up here and create a... Okay, so to put the font, the first thing we need to do is create a variable, a p font class object. We're calling it my font. And then, of course, in here, we need to set it up. So my font is going to equal create font, and we're going to have it be Arial. And we're going to have it 30. Size 30 font. Boom. So that's set up. Now we can start putting text out into the ether. Okay, very similar to the last time we did it. Boom. We need to push, not matrix, this time it's style. So everything in this language is, kind of weird. Pop style. But in here, this is where we're going to be putting all of our information. Okay, so the text size, we're going to use 24. We need to fill, what color? Let's have it white. And the first thing we want to do is text, set the text, right? TimeForDillon, we want that down in the corner. We want it to be 10 away from the left. And what height do we want it? Height minus 50, we'll put it right at the start of that box. So we want it just a little bit lower. 10. Boom, boom. Let's run it, see what that looks like. Draw text. There it is, it's there. It looks good. Okay. So we're literally almost done, guys. Okay, so now what I want is some text in range. So we need to do it like this, kind of like how we did up here. Except we don't need all this stuff in here. We just need like this this if-else type block. Right? Boom. Okay, so basically what we're doing is if the red line is not showing, we want it to be green or white. We'll have it white. So if the red line is not showing, basically we just have to output text out of range. Boom. And that is going to be width divided by 4, because we're going to have 4 things there. We're going to have the name, my name, or your name. It could be your name. We're going to have out of range or in range, degrees, and then distance. So we need 4 different variables. So we're going to divide it by 4. And then we need height minus 10, just so it's at the same height as last time. Boom. Now in this else block, this is where we need to change the color to red. That's really what I wanted to do. So we'll have fill 255 for the red, 0, 0. And then text. What do we need it to say? In range. Width divided by 4. Height minus 10. Okay, now we need to just go ahead and put the angle and the distance. And you know, just to make it a little cooler, we could just copy this. Put it in here. Boom. Okay, so we have that out of range. Now we need the angle, so text, angle, angle, boom, plus, angle, plus, we want the little degree symbol. We want the degree symbol, so there it is. We'll copy it, put it right there. That's how you can always get the symbols into your programs, so you guys know. Boom, comma, width divided by 3? No, 2, because we want it in the middle. And then we'll put the other one divided by 3 over at the end. Okay, width divided by 2, height minus 10. Boom. And then the last thing, text, distance, plus distance. It's literally the exact same as Python. cm, comma, width divided by 3, height minus 10. Boom. Okay, so let's finally run this. This should be it. Bingo. Okay, looks like we need to move things over a little bit. Okay, so you know what I messed up? These two should be down in here, in the red stuff. Because we only want it to show up when it's in range, right? Boom. And then I also kind of messed with the numbers to make it work. So it's 3 times width divided by 4 for the distance. And that should work. So let's deploy it. Boom. It's working. It tells you the angle, the distance. As we close in, boom, you can see the distance going in, the angle, still reading the angle. The only thing that could be fixed is if we have the green line behind the red line as well. But I'll let you guys figure that out on your own. That's pretty much it. That's how you make this radar system work. If you guys want to see, boom, the view, see it's picking it up. You can see that it is literally tracking as this thing is spinning. Boom, it gets to the end, boom, turns around, here it comes. My hand's in front of it. Boom, you can see the line getting smaller, so it totally works. That's really all I have for you guys today. If you guys made it through this video, I know it was a lot longer than usual. Shout out to you guys. If you guys actually made this project, shout out to you guys. That's all I have for you guys today. If you guys made it this far, thank you so much. I really appreciate all the support. Have a beautiful day, beautiful night, wherever you guys are. Dylan is out.